really want to emphasize are the highlighted ones: vertical height, slant height, base. Okay, these three, make sure you know the difference between your vertical height and your slant height. Base is quite easy, but we will require it for our formula later on. Okay, then the rest, just make sure you know what they are. Taking photo means you didn't watch the video. Okay, so I'm not going to go through these. These were already in the video. All in the video. Okay, let's start with this page. Was this covered? Page 5. Page 4, all the pyramids. Okay, let's start over here. Find the total surface area of the square pyramid. When it says square pyramid, the word that comes before the word pyramid describes the base. So in this case, square pyramid means that the base is a square. So we've got 7 cm here as well. Total surface area, we can see that there are 4 triangles and 1 square at the bottom. Because all of them have the same triangles, we can find the area of 1 triangle multiplied by 4. Then add that to the area of the square. So the square is not a problem. What about for the triangle? For the triangle, the area is given by half times base times height. So let's draw out 1 triangle. See what it looks like. So we've got the base of 7. We've got a vertical height of the perpendicular height for this particular triangle is 12 cm. Okay, so area of 1 triangle will be half times 7 times 12. Simple. Okay, so 6 times 7, we got 42 cm. 42 square centimeters. And what about the area of everything? Total area will be our 7 square, that is the base, plus 4 times of 42. You can actually combine all the steps by writing 7 square plus 4 times of half times 7 times 12. So combine everything, we will be able to understand. So total of 217 square centimeters. So total surface area, pretty straightforward. For a square pyramid, where all the triangles are congruent, so far so good. That's something you could have done in primary school also, right? So what's the challenge? Well, what about this? Okay, please try this out yourself right now. Count properly the number of triangles, and are the triangles all the same? Do you have all the dimensions? So total area 310.5. No need to run off to 3SF if the answer is exact. Okay, now right square pyramid has the same slant height. So we see the phrase being used as slant height. You need to know which is the slant height. Okay, so same slant height for its lateral surfaces. Lateral surfaces refer to those that are not at the base. So we can see that for this rectangular pyramid, is it rectangular? Yes, rectangular pyramid. We've got 4 triangles at the sides. They are the lateral faces. And since it is a rectangle, then the opposite triangles are the same. So we have 2 different types of triangles. But all these triangles, they have, oh wait, they say different slant height, okay? Different slant height. They tell you that the height of the pyramid is 12 cm. This refers to the perpendicular height. Yes? Is that a different question? Oh, why always like that? Oh, wait, this one. Oh, sorry, my fault. I went to the wrong question. Right square pyramid, is this the one that you have? Okay, sorry, my fault. Right square pyramid, same slant height, referring to this distance. Each of the triangle will have the same slant height as shown. Base 2 cm, the length of each edge 2.7 cm. So edge refers to this portion. So over here, this will also be 2.7 cm. Okay, so make sure you can visualize the pyramid. So now find the slant height for the lateral face triangle VBC. What I find useful, very, very useful, is to draw the triangle VBC. Because in a 3D diagram like this, you might be overwhelmed with a lot of information. Isolate what is important to you first, that is the triangle. And I've mentioned Sec 2, right angle triangles, very important. So whenever you can isolate triangles, you can look at it closely again. Is it going to be a right angle triangle or not? Turns out in this case, no, it's not right angle triangle, but still isolate it. So V, B, and C. Put in all the relevant information you have, 2 and 2.7 as the edge. They want the slant height. So in your own triangle, write down, indicate your slant height. The slant height is going to be the perpendicular distance from V to BC. Let's call it H. Okay, so now, how then do we find the value of H? Any suggestions? Aloysius? Any suggestions? I notice your hair, that's why I call you again. Maybe every time you don't cut hair, I just keep calling you. Yes, Aloysius, what do you think? How to find the perpendicular height H? You can do it. What does your gut tell you? Don't look at Harry. Is it a tip of your tongue? Look like you want to say something, but tangent sine cosine. Tangent sine cosine requires angle. Tangent sine and cosine will be related to angles. In this case, you can find angles, but that's not the most efficient way of doing it. It can work. Try something else. Sec 2, triangles. What kind of triangles are we looking out for? Right angle triangle. Right angle triangle. Got right angle triangle? Have or don't have? If you see right angle triangle, what are the two things you should think about? Can you use Pythagoras theorem? Okay, how? Good. This is the key. When you see this type of question, you have to realize that the dotted line actually cuts BC into two equal parts. So we've got 1 cm here and 1 cm. So then he has isolated from this triangle 2 congruent right angle triangles. And then since he said Pythagoras theorem, it means that H is going to be square root of 2.7 square minus 1 square. This is going to be the perpendicular height of this triangle, otherwise known as the slant height of each of the lateral face triangle BBC. I'd like to find out the value 2.7 square minus 1. The exact form first. So square root 6.29. Then I evaluate it out to get 2.5079. Round off to 3 as 2.51 cm. I like to have the square root 6.29, which is exact first. Most likely, subsequently, we will have to use the information. Then when you have the slant height, just put it back into your triangle that you have drawn. Does it make sense? Does it make sense for the slant height to be 2.51? Does it look correct? So you should be comparing with the hypotenuse, because the hypotenuse has to be a longer side of 2.7. Anything smaller than 2.7 should be okay. So now find the total surface of the pyramid, which you can do already, because you've now got the perpendicular height. Total area will be 2 square, that is the base, plus 4 of those same triangles, half times the base, which is 2, times the perpendicular height. So what will you use as the perpendicular height? Square root 6.29, 2.5079, or 2.51? Yeah, there's the best answer, which is actually square root 6.29. There's a okay value, that is 2.5079. There is a number you should never use, which is 2.51, because that is 3SF already. So total value, total area over here, 14.0319. So you can write down notes. This will be 4 triangles. This will be area of 1 triangle. And this is our perpendicular height of 1 triangle. These are notes that you can write to help yourself. Okay, next one. We have practice 4, irregular pyramid. Please try yourself now for the slant height for each of the lateral faces, VQR, VPQ. It is the same as what we've done before. It's just that now you have 2 different triangles instead of 4 of the same triangles. So please try it now.